Hello everyone, my name is Brad Su and I'm the Product Marketing Manager at commercetools. Welcome and thank you for joining today's webinar. In today's session, our Chief Product Officer Kelly Gage will be talking about how to get ahead in modern commerce with GraphQL. He'll take you through points like how GraphQL came about, who it's for, and how it's relevant for commerce, the limitations of REST APIs and how GraphQL helps overcome them, as well as key concepts and examples of how GraphQL works and more. Feel free to ask any questions that you may have at any time during the course of this webinar by typing your questions into the box located in the webinar program's interface. Towards the end of this webinar, there will be a Q&A session to answer the questions from this webinar. We'll also be recording this webinar so that you can review it at a later time. And with that, I'll hand things over to our speaker, Kelly.
All right, let's get started. So thanks for taking time to join me today. I'm really excited to be talking about GraphQL. It's been my hobby for the past year plus, and I'm really eager to share it with all of you. So quick background on me. I started my career with ATG, which was the commerce leader back in the 90s and 2000s. I was an architect there. And then after ATG was acquired by Oracle, I went into the cloud product management group within Oracle. And I got kind of bored, so I wrote e-commerce in the cloud. Really loved the intersection of commerce and cloud. And this was right when large-scale commerce was actually starting to use cloud for the first time. And then my last year at Oracle, I was responsible for microservices. So by that point, I had done commerce, cloud, and microservices. And I thought it was such a natural fit for commerce that somebody had to be doing it. And I found out that it was actually commercetools was the only one on the market in 2015 and 2016 that was actually doing commerce cloud and microservices in any meaningful way. So I joined in 2016. I've been with the company now for almost 4 years, and I am Chief Product Officer. And I've written 3 books since then, and my last one is GraphQL for Modern Commerce, which is what we're here to discuss today. All right, first, REST. And in light of current events, I encourage you all just to take a deep breath and picture yourself on a beach somewhere and try not to get mad at your canceled spring vacation plans like I am. All right, so challenges with REST. REST is the standard mechanism for exchanging data between systems. So as a client, you make a request to a REST endpoint and you get back some data, right? It's pretty straightforward. And it is very powerful, but it has challenges. And REST is really oriented around the back-end developers. So you have a small microservice teams, and each of those teams of 5 to 9 people roughly, with an average of 7. Those teams of people are responsible for exposing functionality through a REST API. So there's a team of, say, 7 people, and within an enterprise, they're responsible for exposing inventory to the whole company. And the way that they do that, the front door to their application is through a REST API. And it makes perfect sense for them to do that because you want to control what you're exposing to the world, and you do that through your REST API. So that actually works out really well. And then you have multiple clients as well. And a client is just something where commerce can happen. So that could be a point of sale system. It could be a web page. It's something in the front end. But historically, APIs are very back-end oriented. I don't know if you like my Photoshop skills. I threw this together this morning, given current situation. Generally, there's a very big shift in the industry from back-end to front-end. And that's because if we go back a slide, there are lots more front ends than there are back ends. So a traditional commerce application has mobile, maybe a couple flavors of mobile, a couple flavors of web. There's IoT, it has AR, VR, it has voice interfaces. There are lots and lots and lots of different front end developers, not back end developers. And on top of that, you also have issues with overfetching. I'll talk about these all more in a minute, but you have overfetching, you have underfetching, you have the lack of any real standards with REST, REST is more of a principle and set of principles than a standard. And you also have a lack of discoverability. So I'll talk about those four in a second. So the first issue you have is overfetching. And if you're building an Apple Watch application, or you just want to, on a web page, display the product name and the image and the price, the challenge you have is when you call the product API, you have to, you get back potentially 100 or 200 different fields. You get back lots and lots and lots of data. And platforms like ours, I mean, there are ways of minimizing the amount of data that gets retrieved, but then you have to specify exactly what's called. And that gets really hard. It's not a real standard between different providers. So with commercetools, we have one way of doing it. Maybe your payment gateway has a different way of doing it. Your internal APIs, it's another way. There's no real standardization. So you end up retrieving lots of data that's just discarded. And that gets really difficult when you have very low bandwidth connections. So think of cell networks and things like that. When you're trying to retrieve a product, and you have to retrieve 100 different fields for that product over an Apple Watch, that gets really expensive network-wise. Another issue you have is underfetching. So when you underfetch, that means, let's say you have to render an order details page. You might have to call the customer orders API, and then the orders API, and then the shipping API. You have to call lots of different APIs, and a lot of times you have to do that sequentially, and there's a lot of latency involved. So you're underfetching pretty dramatically, and you have to make many, many different calls. And that's really bad from a performance perspective as well. There's also a lack of standardization. Again, REST is more a set of principles. Roy Fielding in 2001, his famous PhD dissertation at UC Berkeley, he was the one who defined what REST is, but it really is truly a set of principles. It's not a specification. There are a couple standards out there, but they're not widely used, and people tend to use different standards. So they're all over the place in terms of what they use. And there are different formats of data. Again, if you're in an environment where you have to call 30 or 40 or 50 different APIs, and you have to call each one slightly different, then you have very serious problems. So the lack of standardization really hurts. Another challenge is within enterprises, there's a lack of discoverability. So if I'm a client developer, if I'm building an iOS app, right? If I'm building an iPhone app, I need to retrieve a product inventory. It is not uncommon within enterprises for there to be 5 or 10 different APIs that hold a product inventory. And what I mean by that is you'll have an OMS, you'll have an ERP, you'll have a WMS, you'll have a commerce platform, you'll have various caches. So it becomes very challenging if I'm a front-end developer to know which API to call. And then on top of that, you have to authenticate, you have to know which fields there are, you have to, there's a lot of variability in all of those different APIs. So that becomes really challenging. Let's take a look at a real life example. So this is the order history page on Amazon. And if you look at this page, this is a pretty standard page here. You have to retrieve lots and lots of data to render this page. So you have to retrieve orders, products, SKUs, prices. There should be a link to track shipping if that's enabled, shipping speed. There are a lot of different APIs you would have to call here, and that becomes really challenging to render. And you can call each API separately. So you would call the customer API, and then you'd call the order API, and then you'd call the product API, and then you'd render your page. But there you have to deal with overfetching and underfetching, as we talked about before. And also, as I discussed before, it's very hard to figure out which APIs to actually call. How many solve this is they use a backend for a front end, it's called, or it's an aggregator pattern. And there you basically build a microservice, and all that service does is it exposes one view of one bit of data for a specific client. So you might have an iPhone category detail API, right? And all that one does is call all of the appropriate APIs, and it does all of the filtering and retrieving of data, but it does it from within the data center. So you're not having to go over the network, over the public network here. Instead, you're just doing it directly over the private network. And it is faster because you have basically unlimited bandwidth and no real latency to deal with. But that becomes challenging because now you have lots and lots and lots of these backends for front ends that you have to maintain. So you have to have an order history page for the desktop, for the mobile web, for iPhone, for Apple Watch, right? Take your pick. You now have X number of pages or views times X number of clients. It's not inconceivable that you could have 50 or 100 or 200 of these things. And again, we at commercetools deal with these problems today. We do have mechanisms in place to deal with them, but GraphQL is much, much easier. All right, so let's talk about GraphQL. This actually came out of Facebook. If you look at graphs, right, there's graph theory. A graph is a set of nodes with connections between them. So there are social networks like Facebook. There are transportation systems, so think of airports, right? And you have points, right? You have cities where you have people or you have companies, and then those cities or people or companies have relationships with other objects. So Minneapolis and Detroit, I have a very, those are both Delta routes and they're very heavily connected. So you see a connection between those two cities, right? So those are two nodes in a graph that have a direct relationship. And it's the same with people, right? With Facebook, right? I'm friends with my wife on Facebook. She's friends with me. It can also be the same with Twitter. That's an example of a unidirectional graph where I am following Barack Obama, but Barack Obama doesn't follow me. So that's another example of a graph. And commerce is actually a big graph as well, if you think about it. So you have orders and you have customers and you have products, and they are all very connected to each other. And GraphQL is a query language for graphs. So think about it, it's graph query language, GraphQL. And the whole concept of GraphQL is the client developer can issue queries, and those queries are almost like SQL queries, right? Where you can specify for this product, I want to retrieve the name and the price and right X details. And then the GraphQL layer will go through and actually retrieve all of those bits of data from the various underlying APIs or databases or source systems. So GraphQL is built for front-end developers, and it's built in recognition that front-end is overtaking back-end. It complements REST APIs, it doesn't replace them, and it allows front-end developers to create queries for data without regard to where that data is or how it's retrieved. GraphQL then will actually go and retrieve the data for you. If you were to think about this in terms of databases, traditional relational databases, REST as we have it today is the equivalent of querying individual database tables. SQL is the equivalent of GraphQL, where you can query lots of data from lots of different tables all at once. And Facebook actually came up with GraphQL itself. So they began using it internally in 2012. It was actually called Supergraph at the time. And they released the spec in 2015, along with a reference implementation. And they did maintain control in name only, but they did allow a lot of community participation since 2015 onwards. But GraphQL was invented by Facebook because Facebook has the same problems with REST that everyone else does, which is overfetching and underfetching. And they have those problems much worse because if you think about it, Facebook has 3 billion active users. It's a lot of users. It's a lot of different clients that they have to support. And they came up with GraphQL because in 2012, they were going to rebuild their mobile application because at the time, the mobile application was just a thin wrapper around a website. And it's a very poor user experience. So they came up with GraphQL as part of the switch to a native app. And for GraphQL especially, it makes, for Facebook especially, it makes GraphQL is perfect because, again, a social network is just a big set of graphs. And the current state of GraphQL is actually looking really positive. So there was a formal GraphQL Foundation, right, a top-level Linux foundation for GraphQL, and that is huge. So most of the technology we use today, whether it's containers or Kubernetes or service meshes, all of that is actually part of the Cloud Native Computing Foundation. Linux is part of the Linux Foundation. Like a lot of the technology, I would say 80% of the technology we use out there on a regular basis is part of the Linux Foundation in some way. And for them to give GraphQL its own top-level foundation is a really, really, really big deal. So that foundation is now open. It controls the specification and the reference implementation, and it is a very active foundation with lots of users, and they're doing a great job with it. These are some adopters of GraphQL. Facebook, of course, was the first. Twitter was a very early adopter of GraphQL. And actually, one of our developers wrote Sangria, which is the Scala implementation for GraphQL. That was used by Twitter. So every tweet you've seen for the past 4 years has gone through a library that one of our developers created. Same with New York Times, they use the same library called Sangria. And then lots of other companies support it as well. So the big cloud vendors do. Shopify just came out with some support for it, which is great to see. GitHub has been a very active vocal user, but there are thousands and thousands of users out there. And here are a couple benefits. The first, and I think the biggest is it allows you to have much, much easier front-end development, because now developers don't have to care about overfetching or underfetching or discoverability or standards or any of that stuff. All they do is they hit the single GraphQL endpoint, and that GraphQL endpoint then has introspection, and it shows what types are available, what queries, what fields, everything. It makes it really, really easy for front-end developers to very quickly iterate. And they can ask for data and get exactly the data back that they want in the exact format that they need. There's obviously performance benefits because now when you render a page or a screen, you're executing a single query. That's it. It's all you ever do is execute one query. And the development is a lot streamlined as well because all of your authentication, authorization, all of that stuff is all pushed to the GraphQL layer. And there are very specialized tools that deal with it there. I don't think that front-end developers should ever have to worry about any of those topics like permissions or authorization, authentication. And that becomes a very big problem when you have to retrieve data from lots of different APIs. This is an example of a query in GraphQL that avoids overfetching. So you have your query for products, results, right? And you can get back exactly the data that you want, but you can do it in a hierarchical format. And I'll talk about this more in a minute. Here's an example of a query that avoids underfetching. So again, you're getting back everything from lots of different sources. So everything can come back in one single query. And this is an example of introspection. And this is something that REST lacks, and that's really challenging. With REST, you can't look at what fields are supported, right? You just have an endpoint and you have to issue a query to it and hope that you have their specification. But with GraphQL, they allow you to actually look, the language supports introspection, looking at what is defined in the schema definition. And using introspection, you can do things like autocomplete, for example, like you're seeing here. So it becomes very, very easy to discover what is available through a particular endpoint. All right, next, let's talk about the spec, the clients, and the servers. The specification is a very long, it's 216 pages when printed. In excruciating detail specification that defines what GraphQL, the syntax is for the language, the schema definition language, It defines how clients should work. It defines how servers should work. And what's nice about it is it's so specific. It's very, very, very detailed. So there are rules there about syntax, about quotes, and the actual ASCII format of the quotes. There are rules in there about spacing. There are rules in there about the ordering of arguments. I mean, every single thing that you could possibly look at or possibly imagine with GraphQL is covered in the specification. There are a few things that aren't covered, but the vast majority, absolutely everything is covered. And what's nice about that is you have interoperability. So GraphQL server that conforms to the spec will work with any client, and that's not something you get with REST or anything else. What's not really in the spec is clients are covered to some degree, but not entirely. Combining schemas. So if you have multiple GraphQL endpoints, there's third-party commercial tooling that allows you to merge those schemas together. There's also security, there's caching, those things are left up to the client and to the vendors. So these are some key concepts. GraphQL allows you to define what's called a type, right? In this case, this type is a product. Think of a type as a noun. It's an object. It's a thing. You can then define multiple fields. So product can have a name. It can have a description, price. The fields can all come from different sources. So in our system, right, the name of the field, the name is separate from the reviews, right? Those are two separate REST endpoints in commercetools. But using GraphQL, you can actually combine them together as one. You can define primitive data types, so string and float and all those things. You can define whether it's required or not required. You can define non-primitive data types. So you can say for this product, this is its parent category, and that's the link to the category. And then you can also define arrays. So you can say, for this product, these are its reviews, and here is an array of reviews. So you can get very specific about defining your schema. A key concept with GraphQL is, as the name suggests, it is about graphs. So you can define a customer type, and the customer type can have an orders field. You can also define an order type, and that can have a customer field. So you could then reference customer.orders or orders.customer, right? So there's a bidirectional relationship there between those two, which is pretty powerful. You can define multiple operands. So you can define a query, and a query actually retrieves data. You can also define a mutation. A mutation updates or deletes data. You can also define a subscription. A subscription is what Facebook invented for their like follows. So if you're on Facebook and you see on the upper right-hand corner of Facebook, you start to see a notification that somebody liked one of your posts. Behind the scenes, that's actually a GraphQL subscription type. Then you have your query name. You can pass in arguments if you'd like, or variables, and then you can pass in your field names. And again, you can get as hierarchical as you'd like with that. These are the results. This is the result of a very, very basic query, and it's in JSON format. So data is always the key, and then this is the product, the category, and the name. So you can see everything just neatly right there. Clients are what run on the client side. So think of your web app or your native app, and they're basically responsible for the HTTP request handling. It's really what they're there for. It's up to them, to the clients, to take your query and post it to the GraphQL endpoint. And it does authentication, request handling, error handling, caching. Those are some optional things that they can do. But basically, you could do it using curl if you wanted to, right? All you're doing is you're passing a query to the GraphQL endpoint and then getting the response back. So it's primarily about request handling. Almost everyone uses Apollo. Apollo is a company very widely used across the GraphQL ecosystem. They kind of have a monopoly on this. Very, very powerful stack. So I would highly recommend Apollo. Error handling is defined in the specification. This is the format of errors. So you'll see the errors key, and then you'll see one or more of these where you have a message, locations, path. You can do caching as well. Caching is a commercial feature. Apollo supports it, for example. You can do it, again, it's implementation specific, but you can define age at the type level or at the field level. And that actually works pretty well. GraphQL servers are defined in the spec in excruciating detail. You can go out and pick whichever one you want. GraphQL.js is the standard one that Facebook released and has been working on now for 5+ years. Lots and lots of folks in the open source community have contributed to it. It is kind of the standard out there. It's the most fully featured server available in the market. It's really well done. There are lots and lots and lots of other implementations of GraphQL. They have ones for Java, and take your pick of obscure language, they have one. And they all conform to the spec. So you can take a client, a random client, and the server will respond the exact same way every time, even though the server is written in a completely different language. And that's what that really nice tight specification allows you to do, is have interoperability. And then note, you actually have to wrap the server with an HTTP server. So there's the GraphQL engine. The engine builds the type schema, it validates the queries, it executes the queries, it retrieves the data, but the HTTP server is responsible for actually accepting the accepting the request and then returning the response back to the client. So just a quick difference there. And then inside GraphQL, there are what are called resolvers, resolver functions. This is an example from GraphQL.js. So every field in your schema definition, in this case name, has to have a matching resolver function also named name. And this is a very simplistic example, but if the product is not in the context, retrieve the product and then retrieve the name of the product and put that product in context. Because what you don't want to do is make a REST call for every single field that you resolve. Instead, you want to make one call, retrieve the product, and then have all of your different resolver functions use that cached version of that product for the duration of the request. But this right here, where you say fetch something, that can be anything. You could execute a database query. You could call a third-party ERP system. It doesn't matter how that data is resolved. I think it works really well to do REST, and that's why we recommend that it should complement REST, not replace REST. But just keep that in mind that every field must have a matching resolver function, and that's kind of the magic of GraphQL. That's where it all happens. All right, next, our support for GraphQL. These are two quotes. These are the heads of customer success in the US and heads of customer success in Europe. They are seeing it absolutely everywhere. Almost every one of our customers is using GraphQL or plans to use it in the very near term. So it's great to see how quickly it's caught on out there. Again, it's just incredible how quickly it has taken off. We firmly believe that, and it's actually in the subtitle of the book, that GraphQL should complement REST, not replace REST. And the reason is behind the scenes, we use microservices, and lots of folks use microservices. The API, the REST API that the microservice team exposes should be REST, because what you don't want to do is have a middle layer, almost like the SOA layer from 10 years ago, that then becomes a monolith by itself. You want the backend teams to expose their data and functionality through the REST API and leave it exposed through the REST API. And then you want GraphQL on top of that to retrieve that data. But what you don't want is a huge GraphQL server in the middle that has tons and tons of business logic, because now you've created a monolith in your pipes, which is completely opposed to the whole concept of microservices to begin with. You want each team to have the autonomy to release to their release to their REST API whenever they want to. So that's a big difference. We were the first commerce platform to support GraphQL. We have the most coverage of any commerce platform in the market. We're almost 100% for queries, and we're making rapid progress towards 100. And then we also support mutations. We're probably 65% coverage on mutations. So you can actually use mutations to change data on our platform. We're the top sponsor and organizer of GraphQL Europe. And we are very active in the open source community. So we love GraphQL. But again, it's a complement to, not a replacement for. And one of our developers, Laura Louise, she's amazing. She posted some great stuff on GitHub. If you want to take a look at some code examples, you're more than welcome to have a look. She has a couple stores and code snippets and reference implementation. So pick your poison here, whether Vue or React. But it's all here if you'd like to take a look. And then finally, you can learn more through our GraphQL booklet, which was just released earlier this month. And there you can learn much more detail about the specification, about getting started, how it applies to commerce more. It applies in great detail. So if you find yourself with a little bit of downtime over the next couple months, it'd be great to curl up with next to a fire, pass the time a little bit faster. All right, with that, I'm going to open it up to Q&A.
Thanks, Kelly. That was a great speech that you had. From the viewers, I have a couple of questions. Just to let you guys know, you can still feel free to continue asking questions as I'm reading and working through our list. It's available on the chat/questions tab in your GoToWebinar screen. The first question I have is, what is the extent of complexity for adopting GraphQL for a company that's right now using just REST APIs?
I think it's pretty easy to get started. What's harder is to get 100% coverage. But if you want to throw up a GraphQL server today, that's actually quite easy. You could put a server up in front of your own APIs and then merge that with our APIs. If you wanted to, if you're a commercetools customer, you can just start hitting our GraphQL endpoint right now. It's all right there. It's all really well documented. And if you're a customer, it's all free to use. And I would start with reading the booklet. I think it would give you some very good pointers on how to get started. But start small and pilot it and see where that takes you.
Sounds good. We just had a fresh question in here. You mentioned 100% coverage of GraphQL. What does 100% coverage mean?
We're getting there, so it's not a done deal yet, but we're pretty close. We're probably in the 90% range right now. What that means is that every single REST API that we expose, we have 300 different APIs that we expose, means every one of those is covered with our GraphQL layer. So what we would like is in the near future for all of our customers, if they wanted to use 100% GraphQL to access our functionality. And if you look at our competitors, Shopify, Magento's added a little bit of support. They're down around 10–15% coverage. So we're 90+% for queries at this point. So we're making pretty good progress, but we still have a little bit of work to do.
All right, sounds good. I hope that also answers the question of which APIs we don't cover yet. I think that's a pretty long answer, and also something that you could refer to in our documentation. I'm going to skip over to our next question. What is the drawback of GraphQL? And by that, I mean, would it affect how dynamic my business works or face any performance issues?
Well, it's actually a lot GraphQL is much faster front-end development. The challenge with GraphQL, there are two issues with it. The first and the biggest is that you can end up with a monolith in your pipes. And what I mean by that is the GraphQL layer can have too much business functionality in it. And you can end up with very coupled applications. So the GraphQL layer can then be coupled too tightly to your microservices. And then you have a problem because now you've recreated the SOA model, right? Where you have one big monolith in your pipes, and then that becomes wedded to your backend applications. And then everything has to change all at once rather than allowing any piece to work independently. And as a company, we're really committed to adhering to the principles of microservices, which means allowing each microservice to be able to be updated independently. So I have seen people do that, and they take to GraphQL a little bit too eagerly, and then they start using it for everything, and they neglect REST, and then it becomes a monolith in the pipes, and then they're back to SOA from 2005, and that's a problem. That's not something we want to see. The other issue, it's more of a technical one, and it is being resolved, is combining multiple schemas. So imagine, and we have a couple of these customers as well who are all in on GraphQL. So for their loyalty system, for search, for content, for commerce, there are vendors for each one of those. And the problem is if you have 4 or 5 different GraphQL endpoints, GraphQL can now look like REST APIs because now you have to call to the commerce endpoint for the product information. You have to call to the content endpoint for the content information. And it kind of defeats the whole purpose of GraphQL if you have to make calls to different endpoints. So Apollo, again, they're kind of the leaders in this space. They came out with schema stitching originally, and that allows you to merge multiple schemas. And they've replaced that with schema federation. And it actually works out really well, but you do need some consulting from them to get started with it. It is kind of technically complicated. So I expect to see very rapid progress on that over the next couple months, 6 months plus.
All right, next question. Is there a point where an app or website would benefit from REST better than it would with GraphQL? This comes from a viewer who has right now a few products and some web pages. And in other words, is GraphQL overkill for a smaller project?
Yeah, it depends. If you have one client, then GraphQL probably isn't all that necessary. What else? If you don't have the technical competence to do it, that can be quite difficult, right? It is a learning curve. You do need to learn some new concepts and new technologies. Then I probably wouldn't recommend it. If you don't have that many REST APIs anyway, right? If you have kind of a monolithic application and you expose everything through REST APIs, and you only have a handful of APIs that you expose things through, then you probably don't need it. Yeah, I think those are good reasons not to use it.
Yeah, sounds good. And I think that kind of echoes our recent blog post talking about Forrester's report on how you should find something that fits your needs in terms of commerce platform. You should also pick either one, right? Like to fit your development team size.
Yeah, and you have to be pragmatic about new technology because every 6 months there's a shiny new toy that if you just chase those, you'd be like a dog chasing a car, right? You never quite catch it. GraphQL has been around for 5 years now. It's doing really, really well in the market. We're seeing everyone adopt it. GraphQL is a safe bet that you can start using now. But again, it does have drawbacks. It does have trade-offs, right? It's another layer you have to maintain. There's more skills that you have to have, and it's a trade-off because you're trading front-end development, right? It makes it much, much, much easier to iterate on your front ends. You're exchanging that for more work on the back end because now you have to have this GraphQL layer, and you have to have all of these resolver functions that retrieve data. So, I mean, there is no such thing as a free lunch, right?
Yeah, precisely. What kind of versioning works with GraphQL?
GraphQL evolves, it does not version. So they
Cool.
make their APIs backwards compatible, they don't version them.
And yeah, so I think we're approaching some more technical questions right now. So I'm just going to group them together based on the overall theme. So we're right now going to focus on some technical questions, and then we'll move on to how commercetools specifically supports GraphQL. Is that fine with you, Kelly?
Sure. Yeah.
Okay, cool. So what makes GraphQL faster than Solr, Elasticsearch, or a direct database transaction?
Well, they're different. So Solr and Elasticsearch are search engines that are responsible for searching for products or orders or customers. And if you type in like a blue shirt query, then you get back blue shirts, right? That's more what Solr and Elasticsearch are doing. What GraphQL does is it allows you to query across multiple APIs. So in most enterprises, you have APIs and microservices everywhere. You have teams and applications exposing APIs. GraphQL is the bridge that allows the front-end developers to retrieve all of that data from the back end very efficiently and quickly. So I would say they're conceptually very different. They're solving different problems. And you would never want to query the database directly from the front end. That's way too tightly coupled. Security issues there, all sorts of issues that you'd never want to do.
Sounds good. The next question is on how GraphQL fits within a tech stack. What kind of databases and programming languages does GraphQL work with?
You can pick any implementation of GraphQL you want. So there are implementations out there for JavaScript, of course, and I mean JavaScript is the standard basically. I would say 75% of people use JavaScript, but you can do Java, you can do Scala. Take your pick of language. You can do just about everything. So it depends which implementation you want to pick up off the shelf and start using. Was that the entire question?
Yeah, that was the entire question. The next question is how can companies take advantage of GraphQL if they already have a heavily implemented aggregator pattern or a backend for a front end? So in other words, how can they make the switch over to GraphQL and be able to do that to the fullest extent?
I would pick a new application of some sort. So maybe you have a new client. Use GraphQL just for that new client. Or maybe you're expanding your business and you want to do, you're expanding into Canada or you're expanding into Mexico or something like that. Build that whole experience using that. That would be much better. So start small and pilot it out and then go from there.
Sounds like good advice. The next question is, how do you handle B2B authentication challenges? For example, order approvals. You mentioned earlier that front-enders don't need to worry about authentication. So how does that all fit in together?
Well, the authentication is done in the GraphQL server itself. So in those resolver functions where you actually call the APIs or call the databases or call the source systems, that's where you actually have the authentication code. And then in the front end, you can get back whatever you have access to. And depending on your server implementation, it will actually tell you how to deal with permissions. So you could authenticate to an API, get access to everything, but then limit what each client, depending on the client, is able to actually see. because you don't want GraphQL to be a layer that somebody can go in and escalate their privileges to.
All right. The next question comes on in terms of how GraphQL works with REST API. Does it have any implication on latency or performance if you add GraphQL on top of a REST API project or platform?
No, I would argue it's much, much faster. And it's because the client is making a request for data. They're making a single request and they're getting back everything that they need in one response. And with REST, traditional REST, you don't have that ability. You have to call many different APIs. You have overfetching, you have underfetching, you have all sorts of challenges in retrieving data. This is different. Here you're saying, I as a front-end developer need these 5 fields to render this page or render this screen. I'm gonna go get it now. And behind the scenes, yes, it may call REST. In our case at commercetools, we actually bypass our REST layer and we're calling the backend code directly from our GraphQL layer. And that's because we want really, really fast GraphQL performance. But you can do whatever you want. And what's great is within the network, so within the backend data center network, when the GraphQL server is calling all of the REST APIs, that's all done where you have unlimited bandwidth and no latency. So all of the unnecessary overfetching, underfetching, any of that stuff is all done over that really, really high speed network.
Sounds good. I mean, with all that talk about performance and latency, I think it's time for some security-related questions. There's 2 that I have here, 2 distinct questions, but both on security. The first one's, how safe is GraphQL in terms of security? And the second one is, how secure is a GraphQL endpoint for different client apps?
GraphQL is as safe as the backend implementation is. So what you could do, and I've seen some people do this, and it's probably not the best idea, is they will authenticate with an API. That authentication will allow them to do anything with that API. And then therefore users of the GraphQL server will then have access to do whatever they want to do. And I don't think that's very wise. Instead, you can implement permissions within the GraphQL server so that while the server might have access to privileged data, the clients, depending on the clients, don't actually do that. But again, that's all very implementation specific. That being said, Apollo actually does a really good job of this. They have a very robust permission scheme, very easy to do it. And then there are other issues with security as well. And I write about this in the book quite a bit. You could have malicious actors execute queries for the entire product catalog, right? And imagine the response size if you have 50 million products that you're selling and you have somebody trying to denial of service attack you by issuing the same query over and over and over for the entire product catalog, you could start to have issues there. And what you can do is you can assign weights to different queries in the GraphQL server, and then you can calculate a complexity score based on those weights, and the server will automatically reject queries that have too high of a complexity score. And I've seen that work really well. We actually do that internally, and we've actually contributed back to open source some tooling that allows you to do this. But on our side, we're really well protected. Only specific queries are enabled. You can also do whitelists and blacklists if you wanted to. So you could say, I only want to allow a certain number, these specific queries with different variables to be executed. You could also just have blacklists and say queries of this type are just not allowed, or maybe they're not allowed based on the user. But again, that's where commercial tooling like Apollo really comes into play.
Sounds good. And in terms of errors, how do you work with, how are errors handled in GraphQL? Like, what does the client see if something fails?
Well, that's up to how the client handles it. But the server will throw up, and it has to be in a very specific format. It'll tell you what happened. It'll tell you what line. It will tell you what character. It's very, very specific, but that's up to the client then to decide what to do with it.
Sounds good. So I think in the interest of time, we're going to move over to some commercetools implementation specific GraphQL questions. The first of which is you have GraphQL right now as beta, and would it be safe for us to use it in a production project?
Yeah, we joke internally that we have German beta, where German beta is kind of like Google beta, where things just stay in beta forever and ever. We're getting it out of beta. We are working on that. Hope to have it out of beta by the end of this year. The challenge is we still have the ecosystem is changing quite a bit around it. And as a vendor, once we take something out of beta, that means we can't really touch it again. And we want to keep our options open so that if there are some significant changes within the GraphQL ecosystem, that we can still make changes. That being said, I would say more than half of our live customers in production today are using GraphQL, so it's very widely used. It's completely supported. Again, we'll remove that flag once we're really comfortable that the ecosystem has solidified.
Sounds good. The next question comes about GraphQL and our recently relaunched product search. Does commercetools support product search through GraphQL?
No, not yet. That's one of the very last areas we have to tackle. We'll get there. It's a lot of work for the team to relaunch the search, and we cut that from the scope just so they could get the new search out because people really wanted it. But we will go back and add support for that later.
That
And I
sounds
should
very
mention, internally, we have a definition of done, which has recently been amended to include GraphQL support. So going forward, something will not be considered released and done until it has GraphQL support as well.
Yeah, that makes a lot of sense. And for those who want to find out more, we have two blog posts, one on our internal definition of done and the other on how we redesigned product search, available on our tech blog, techblog.commercetools.com.
Yeah.
The next question is, do you plan to support fetching custom objects in GraphQL?
At some point, I assume we will. Yeah. We're not there yet, though. Valid question.
Yeah, I'm getting a lot of questions about those little small gaps that we have, but as Kelly mentioned earlier on, we are at a really high percentage of GraphQL support, the highest among all the commerce platforms. So if you have a question on when we're going to support X, the answer is soon, because we are working on achieving full GraphQL coverage as mentioned earlier in this webinar. So with that, I would like to thank everyone for attending this webinar. There will be a recording that's made available to you guys after this. Be sure to visit our website, commercetools.com, to learn more. Subscribe to our newsletter, and also check out Kelly's new book, GraphQL for Modern Commerce. You will be able to get that on the slide in Kelly's deck, and we'll also be sharing that link with you guys along with the recording. Thank you so much for attending this webinar. Thank you, Kelly, for speaking, and everyone have a great day.
Yeah, thanks everyone.